So once you've created each of those, what it should end up looking like is these three different ones, right? So we've got the Gruiformes, we have the Pastoriformes, and then we also have the Statiformes, right? And so each one of these, you can kind of see what's happening in each location. And you can see that they overlap, right? So there's some parts in Austin, there's a little bit in San Antonio, down at the border here, some parts of Florida, where all of these exist, but not all of them do. So this becomes a little bit of a Venn diagram. And this is one of the useful things in creating this ranking system is that we're really interested in the places where everything exists, where everything overlaps, so that we can find the best places to put things, right? We want to rank these things based on where things are located. So you should, at this point, have a couple of different things, right? You should have each of these point things. For the most part, no, not for the most part, we are not going to need these anymore. So I just removed them. I didn't delete them, I just removed them. So now what we're going to do is we're going to want to go back and we're going to want to add our census tracts now. So now what we end up with, right, is we have each one of these densities. Now in these things, if I go to the properties and I go to the metadata and the source, what it'll show me is that I now have a raster one. Each of these rasters should have a 0.01 by 0.01 cell size. Each one should be made up of around 2,000 columns and around 700 rows. So looks a little bit different, right? And if I go here, you will also notice that this attribute table is grayed out. There is no attribute table here, right? So there's no attributes, there's no topology, there's nothing in this case that will lend itself to that sort of thing. So if we want to find the best areas, if we want to combine these things together, we can do various different things, but for the purpose of this, we are going to do what are called zonal statistics. Now, zonal statistics are going to essentially put each one of these, I'm just going to change the symbology on this so that you can see through it, right? So what it's going to do is it's going to take each one of these, right? So each one of these polygons, and it's going to cookie cutter the rasters underneath it and average these values out, right? So over, let's say, this Holiday Beach one, it's going to cookie cutter this one out, and it's going to say, okay, so in, I believe that one is the Gruiformes. In the Gruiformes, it has some sort of average value in and around 39,000, right? And then it's going to go, and it's going to say, Pastoriformes, there's nothing in that one. What about the Statiformes? Well, there's also nothing in that. And it's going to do that. It's going to average those values for each one of these things, right? So maybe in Brownsville, this looks a little bit different. It's going to have this average value here, and we are going to have a different average value for the Pastoriformes and a different average value for the Gruiformes. But it'll go through each one of those and average out those values. Now, with these, this is also why we have to have a bit of a Goldilocks problem, right? Because these polygons are pretty small. And so we want to make sure that we're actually getting a decent average value. Now, you can see that, these pixels are not necessarily as small as some of the areas, but it's pretty good. And that was why we chose that 0.01 instead of something like 1, where there would just be one value for each one of these different things. So again, a bit of a Goldilocks problem. We don't want too much because then it's just artificially that way, and we don't want too little because, well, then we don't get any sort of useful thing. So that's what we're going to do. So we're going to go back to our toolbox, right? So we're going to go to our geoprocessing tools, and we're going to start typing in zonal statistics. Zonal statistics, you'll notice there's a bunch of them. Most of them are going to try and have a raster output after the fact. That is not what we want in this case because we want something a little different. We want to make sure that then we have some sort of polygon after the fact. Now in ARC, unfortunately, there is not a good way to do this. Instead, what you have to do is this zonal statistics as table, and this will create a table with all of your average or whatever statistic it is that you want for each of your raster layers. After that, then you can join this back to your polygon layer. So in this case, we're going to click this and we're going to say, I want zonal statistics as table. For this top one, this is going to say, what do you want your feature zone data to be, right? So this is what we're averaging by. So in this case, we want these census tracts, right? So this top one is geometry in, geometry out that we want. We want census tracts out. In this case, we're going to switch this to the lowest level here. This is the FIPS. This is roughly equivalent to the AFGEO ID that we have used in other places. And then our input value raster is going to be the kernel densities that we want out. And so in this case, I'm going to start with Graphiformes, just do it in alphabetical order. And then I'm going to give this table a name. And I'm going to say I want this to be the Graphiformes. Graphiformes. The zonal statistics for the Graphiformes. So there's a bunch of different statistics that you can have, right? You can have mean, maximum, median, minimum. This is not a statistics class, so this is something that as you get a bit of a feel for it, as you get a bit of a feel for the data, just generally speaking, you'll have a better idea about what things you want in this case. For our purpose, we just care about the mean. We are doing an average level of this. Now you will see this output join layer, right? So you might be thinking, this is a great place where we can do some sort of polygon feature out of the fact. Yes and no is what this is going to be. So this will provide you with a temporary layer. However, because we are doing this multiple times, it'll actually break this to do that. And so as we continue going through this, there's no point in doing that because once again, we're just going to have to do this after the fact. So this is not going to be a good solution. If you're just doing it the once, it's definitely a simple way to just get some sort of feature out of it. Just remember that this is a temporary layer, so make sure that you save it after the fact. So we are going to run this, and why did this break? Input zone raster. It's an invalid field name. Oh. Something has happened in my data. I'm just going to re-export these features very quickly. I think what's happened is, so I have the full one already done in this map layer over here, and I think what's happened is that in this particular case, it's trying to feed this in, but because it has a join in the other layer, it's having some issues. So my general solution when something like that happens, so in this case, I got this error, so the zone data is not valid. In particular, this field name is not valid. I just re-output it and see if that is what is causing the issue. So now I've got the census tracts 1, I make sure that I have the FIPS, and I hope that in this particular case, it ends up running it. And we can see that it's rasterizing it, it's computing the zonal statistics, it's updating them, there are some warnings. Some zones may not have been rasterized. What that means is that you'll see some areas over here where there's no data, and so those ones will have not been rasterized because there's nothing to rasterize in this particular case. And then you'll notice that I have this new table here. So if I open up this table, now I have the FIPS, right? I have the zone, I have the count, I have the area, I have the mean. This value here is the one we actually want, this mean value, right? And so I can see what my highest one is. These ones are my top ones, right? And so these 3 ones here, those ones have the highest values. So you're going to repeat this now for the rest of them. So you're not going to change out your feature zone data, right? So you still want the same census tracts out. What you are going to change, though, is your input value raster. So your input value raster is the one that is going to have this kernel ID. This is the one you want to change. So I'm going to do that one. I'm going to switch this name out to the Graphiformes. I'm going to make sure that it still has this mean, and then I'm going to run it there. So now I'm going to run it again, and now I have it over here, and then I'm going to repeat this process for the last one. So then you should end up with 3 of these values, right? So same, we are only working with the 3 different orders of interest for this particular case. And so you ended up with 3 point layers, then you ended up with 3 raster layers. Now you should end up with 3 new tables. So now you have those mean values for each of those tables. The next thing we are going to do is we are going to join them back and put them together to create a ranking system.